Okay. So expressed as an exact value in simplest form. So in the same way, when we multiply radicals, coefficients with coefficients, radicals with radicals, they have to have the same index. We could do the same with division, right? So here, number 1, I can divide 12 and 6, or 6 divided by 12, which is 2. And then I could divide root 6 divided by root 2 equals root 3. Beautiful. So, but sometimes it's that simple. Rarely. Rarely. Maybe in grade 10. Okay? So, number 2, 24 and 6. How many times does 6 go into 24? We don't need a calculator for this. 4. We don't know. And how many times does 6 go into 54? 9. So square root 9. Can we continue to simplify that? Yes. What is the square root of 9? 3. If it's a perfect square, you must evaluate that. And so 4 times 3 is 12. Okay. Now, does 10 go into 5? Well, so, yeah, well, sort of. Can we reduce this? Yeah, we can divide both by 5, and we're left with 1 and 2. Right? It reduces to 1/2. 5/12 is the same as 1/2. So we have 1/2 root 20. Is there anything else we could do here? 20. Yeah, we can simplify 20. 20 is the same thing as what times what? 4 times 5. And so which one will we square root? 4. What is that? 2. So we have 1/2 times 2 root 5, or just square root of 5. Okay. Easy so far? Okay, 3. What is, how many times does 8 go into 32? Does it go into 32? How many times? 4. Okay, and what's the square root of, does it? Yeah? Okay, good. If I can guess, yeah, 16 times 2. Yes, okay, good. Yeah, it's Friday. What is the square root of 4? 2, so our answer is 6. Okay, so recall that if you have 3 divided by -4, is that not the same thing as -3/4? Yeah, we could just multiply the top and bottom by -1, and that makes it -3/4. So normally fractions do not have a negative sign in the denominator. We'd rather write it out front, like beside, even better, -3/4. Or if we must apply it to 1, we apply it to the numerator. Okay? Also, normally fractions do not have a radical sign in the denominator. When we simplify, these conditions must be satisfied. To do this, we perform a process called rationalizing the denominator. Rationalizing the denominator means taking the radical out of the denominator. Beautiful terms. Okay, so to rationalize a single radical in the denominator, it's like a monomial, multiply numerator and denominator by that radical. Why? Because it's the same as multiplying by 1. Would you agree that root 2 over root 2 is the same thing as 1? Yeah, and so if we multiply by 1, anything times 1 is still itself. It's still an equal statement. So if I multiply the numerator and the denominator by the radical that's on the denominator, which in this case is root 2, we're left with 3 times root 2, or 3 root 2 over what? 2. Root 2 times root 2 is root 4, or we can go straight to just 2. Okay, so number 2, what would you multiply the numerator and denominator by? Root 6. Yes, the square root 6. It's okay to have a radical in the numerator, just not the denominator. Okay, what does that give us? Square root of 30 over 6. Can you simplify root 30? Yes. What perfect square goes into 30? Is there a perfect square that goes into 30? None. Does 9? Nope. Does 4? Nope. 16? So we're done. 3. Okay, how else could I write square root of 2 over 3? Square root 2 over square root 3. Is that not the same thing? Yeah. And now what would you multiply the numerator and denominator by? Root 3. So really what we're doing is we're multiplying by 1. Because root 3 over root 3 is just 1. Actually, I should probably just write it like this. Okay, so that gives us root 6 over 3. Good job. Number 4, what would I multiply top and bottom by? Square root of n. 2 root n over n. I find it helpful always to simplify first and then rationalize, because then we're keeping our numbers smaller. So instead of multiplying the numerator and denominator in 5 by root 8, can we reduce 2 and 8? We could divide both by 2, so we can make this as 1/4. Well, so 10 root 1 over root 4, well, what is the square root of 1? 1, so it's just 10 over, what's the square root of 4? 2 equals 5. Okay, so two different situations than you're used to. What if there is a coefficient? Well, that's okay. What can we do first? Could we simplify anything here? Yeah, the 4 and the 2. I mean, if you didn't, let me show you both methods, okay? So let's say I didn't simplify first, and I went straight to rationalizing. What would you multiply the numerator and denominator by? Root 5, just the radical. Okay, so if I did it that method, I would get 4 root 40 over 2 times 5. Okay. Square root of 40, can that be simplified? Yeah. What times what? 4 times 10. And the denominator is 2 times 5, or 10. Okay. Square root of 4 is 2, so that gives me 4 times 2, or 8 root 10 over 10, which simplifies to what? 4 root, no, you only simplify coefficients with coefficients. So 4 root 10 over 5. Okay, so that's if I didn't simplify first. What if I simplified first? What could you simplify here? The 4 and the 2, right? So if we simplified the 4 and the 2, this changes to 2 and 1. Multiply top and bottom still by root 5. It's 2 root 40 over 5. Okay, so really, whether you simplify first or you simplify later, it's all good. Just make sure to simplify at some point. 4 times 10. I find I like to keep my numbers smaller instead of bigger. Now, are you with me? Or are you lost? You with me? Okay, square root of 4 is 2. 2 times 2 gives you 4. Root 10 over 5. Same answer as before. Different means of getting there. I simplified in the beginning, and then I rationalized. I like to simplify first if possible. Oh, good. We ran out of room. Okay, but 7's important. So I'm going to do some erasing. Is that okay? Did everyone get this down? No? Yes? You guys are quiet. It's good? Okay, square root. What are we going to do to rationalize this denominator? Top and bottom by? Should I call on someone? Root 3. What is different about this situation? What rule will we have to use here? Distributive law. It's a binomial. Yay. It's like backwards distributive law. Okay. 2 root. You with me? No? 18 minus 4 root 9, or you could just go 4 times 3, because root 3 times root 3 is 3. All over, what's root 3 times root 3? 3. Good. Okay, where do we go from here? Reduce, and okay, before you even reduce. Okay, 4 times 3, we can, yeah, we're going to simplify some stuff. 4 times 3, and then what else? 18 can be broken into 9 times 2, which is, okay, root 3, 2, so what happens, what is that expression simplified to on the numerator? 2 root 9 root 2, what does that become? 6 root 2, because we have 2 times 3, right? This root 9 is just 3. And so 2 times 3 is 6. Minus 12. Now this is just like when we did, do you remember quadratic formula? Those awesome songs we listened to? Okay, when we simplify here, how could we simplify or reduce here? It'd have to be with all 3 coefficients. Because really what we're doing is in the numerator, could you factor out 3? Yeah. So what would this reduce to? 2 root 2 minus 4 over 1. So do you have to write that? No, we could divide all our coefficients by 3. Has to be all of them. Oops. There we go. Pardon me. We could divide the root 3s. It's so easy. Yeah, because you could divide each one by root 3. Yeah, and so you would have had 2 root 2 minus 4, and you'd be done. That would have been easier. Yeah. Do you see what he's talking about? The root 3, the root 6, and the root 3. Could you simplify those? Yeah. Right off the bat. You would have whoop, straight to the answer. That would have been nice. We took the longer route, the scenic route. I don't know if it was as beautiful. Okay. So rationalizing binomial denominators. So we were doing method A. Let's look at if it's a binomial. So if it's a binomial on the denominator. Guess where we're going to use this fun word again. Conjugate. So if we have a binomial on the denominator, we need its conjugate pair. Because what happens when we multiply conjugate pairs? Are the square roots gone? Yes. So what would be the conjugate pair to, root 5 plus root 2? Root 5 minus root 2. We're making a difference of squares. So we'd have to multiply the numerator and denominator, because we're multiplying by 1. What we do the top, we have to do the bottom, by the conjugate pair. 7 times 5, or 7 times root 5, it's just 7 root 5 minus 7 times negative root 2 minus 7 root 2 all over. When we multiply difference of squares, what's the shortcut? Do you remember the shortcut? just multiply the first ones and the last ones. So root 5 times root 5. We could do this because we know the middle term will cancel. So root 5 times root 5 is 5. Minus, because it's root 2 times negative root 2, is 2. Or 7 root 5 minus 7 root 2 all over 3. Good times? Sweet. Just have to get through this page. And that's it for today. Well, I thought it was, but it seems like it's okay. It's awesome, actually, hey? Okay, try number 1 all by yourself. All by myself. I need a little icon that I can click that and the song plays. Okay, so you have to go straight to rationalizing here. You can't reduce anything because you have to look at all 3 coefficients, all 3 radicals. The second term doesn't have a radical. Okay, put your brackets in. I want to see those brackets. If you're multiplying by a binomial, you need those brackets there. It's proper notation. So now bringing in distributive law, 2 root 50 plus 4 root 10 all over 1. No, I was going to say 100, but it's root 100, or just 10. Okay, so then I can simplify 50 to 25 times 2. And all over 10, right? Yeah. Okay, let's keep going. So then I have root 25 is 5 times 2 is 10. Root 2 plus 4 root 10 all over 10. Is there anything we can simplify here? Yeah. It's not equal to 2 root 3 or 3 root 2 because you can't simplify. So you can't simplify here because it has to be in all 3, right? It has to be in all 3. You have to be able to do both. And you can't. So actually it's not. Okay, and then here we can simplify. We can divide these all by 2. So 5, 2, and 5. And there's our final answer. You should have had 5 root 2 plus 2 root 10 all over 5. Yay! Uh-oh. Uh-oh. Yeah. I was trying to move all this without moving that. I have to lock it in place, but... Okay. I gotta lock this. 1 second. Let's pause this. Okay, the next one. What would we multiply the numerator and denominator by? Do you want to try it by yourself?
Yes.
Okay, try this one. Start with your conjugate. It's not a trap. It's not a trap. Start writing this one down. So you should have 2 root 6 minus 2 root 3 all over 6 minus 3. Or 2 root 6 minus 2 root 3 all over 3. Can you go any further with that? No, that is your answer. Good. Are you ready to try the next one? Let's do it together. Okay? So what would we multiply the numerator and denominator by? Root 6 plus root 10. Okay, so the denominator we're rationalizing. There are some cases in calculus where we rationalize the numerator, but for the most part, we always, unless told otherwise, we always rationalize denominator. Okay, guess what we have to use here? FOIL. Dun, dun, dun. Okay, everyone's best friend. Binomial man. Okay, root 3 times root 6 is what? Root 18 plus root 3 times root 10, root 30. Root 5 times root 6, root 30. Root 5 times root 10, root 50. All over what? 6 minus 10. If you want, you go straight to negative 4. Is there anything wrong with that? We're going to have to bring the negative up later. We'll do it later at the end. But we are going to have, yes, we're going to have to. Okay, moving on. So what can we do here? Simplify. Okay, 18 simplifies to what? 9 times 2 or 3 root 2. Okay, 9 times 2. Okay, 30. Can you simplify 30? No, so what can we do with those 2 root 30s? 1 root 30 plus 1 root 30 is how many root 30s? 2 root 30s. Right? Yeah. Don't overcomplicate it. No need to. Okay, root 50, what product can we make? 25 times 2, so what would that simplify to? 5 root 2. Your AP, we should be able to get to that. All over negative 4. Anything else we could do here? Collect like terms. 3 and 5 is 8 root 2 plus 2 root 30. Uh-oh. Uh-oh, you can't see the 0. All over negative 4. Our last step, how are we going to move the negative out of the denominator? Multiply top and bottom by negative 1. So what happens to all our signs on the numerator? They all become negative. So negative 8 root 2 minus 2 root 30 all over positive 4. Can we? Oh, we're not done. We must simplify. Unbox. Okay. It's called an eraser in real world. What does it simplify to, guys? Negative 4 root 2 minus negative root 30 all over 2, because we can divide them all by 2. Lots of room for minor mistakes. That's what happens with this unit, right? Once you get the general concept down, you just got to be really careful. Like me, I almost didn't simplify. Tisk, tisk, tisk. Careful, careful, careful. What if, let's try 4 now. Do you want to try 4 on your own?
Yeah.
Why not? And then we'll skip 5, because I feel it's the same stuff. And then 6. So if you're multiplying, like whenever there's a binomial, it needs to be in brackets if you're multiplying a binomial of something. Or binomial times a binomial, or a monomial times a binomial. That binomial needs to be in brackets. So you start with your conjugate, root 5 plus 4. Top and bottom. Root 5 plus 4. And good old distributive law. Good old. This is easy. Maybe, maybe not. I think so. Okay, careful. Root 3 times root 5 is root 15. Root 3 times 4 is 4 root 3. Root 5 times root 5. Here is the different squares, right? So just the first and the last. Root 5 times root 5 is 5, but negative 4 times positive 4, there's no square root there. Right? So it's minus 16. Don't put 4. It's not under a square root. It's just negative 4 times positive 4. So 15 plus 4 root 3 all over root 15. Sorry. Better. Okay, are we done? No. Yep. Yes, because I cannot. Yes, you're right. I definitely cannot. It's Friday, and clearly I need more caffeine. Okay. Whew, just testing you, I mean. Good thing you're actually paying attention. Is there also another thing that's wrong with it? Yes. Negative on the denominator. Basically, all we have to do is switch all the signs. If we're multiplying top and bottom by negative 1, becomes negative root 15 minus 4 root 3 all over 11. Yay. All right, here's where the rubber meets the road. This is the test. This is it, guys. This is where you show me if I failed you, and I should just go home, eat ice cream, and cry. Okay. Can you please try this one? Let's do this. So you're multiplying by 2 root 2 plus 3 root 3. You have to make the difference of squares. Okay. So when we do this, we are foiling. So the numerator, you should have 2 times root 4, or 2 times 2, plus 3 root 6, plus 2 root 6, and then you get root 3 times 3 root 3 is just 3 times 3, because root 3 times root 3 is 3. All over, we just need first and last here. So we get 4 times 2 minus 9. 3 times 3 is 9 times 3. So in the numerator, simplifying that, I have a 4 plus a 9, which is 13. Yep. And then we have 3 plus 2, which is 5. All over 8 minus 27 is actually negative 19, but we want to answer with a positive denominator, so negative 13 minus 5 root 6 all over 19. Any questions? Not so bad? Okay, we're done the lesson, so now it's time for homework. Yay! Okay, your assignment. No, you must do, not if you choose to do. You should do. If you choose to accept your mission. Or I don't know. Okay, is. Can we watch a movie? There's always a reason, right? Okay. Grab your textbooks. Page 289, 293, number 6, 8 ABC, 9, 10, 11, 13, 14, 17, and 19. Had to use 2 breaths to say that. Good practice. Okay. Now remember, guys, I recommend you get started now and ask me questions, because guess what's on Monday? Quiz. Do not walk into class surprised. That's my biggest pet peeve. It's when a student walks into class and they're like, oh, we have a quiz today? Woo-wee! Okay? Lots of written, yes.